Okay, so this is a video about the four operations and what happens when things like plus or minus or times or divide, when those symbols get bunched together in the same problem. Now we're going to start with a problem setter on the left, we call them person A, and a problem solver on the right, person B. And I'm just going to draw a dividing line between them so that we can see the different thinking that takes place when person A tries to communicate a problem to person B. So let's just start very simply with no mixing up at all. We've just got 6 plus 2 plus 7. So person B can very happily say, well, I'm not going to do it in that order. In fact, I'm going to say 6 plus 7 plus 2, or I'm going to say 2 plus 7 plus 6. In other words, person B can quite happily change the order of these things and not worry at all about getting the wrong answer just because they've done that. They can also associate, which means grouping, so they can quite easily say 2 plus 7 plus 6. So I'm going to do the 7 plus 6 first and not follow the left to right order of things. So now we've got 7 plus 6 is 13, add the 2 gives us 15. And person A should be happy that they've done all this because they've got the right result. Person A might have intended 6 plus 2, which is 8, plus 7, but the result equals 15, matches the result that person B got. So everything's fine. But what happens if person A sets a problem like this? 6 subtract 2 plus 7. What we're doing here is we're mixing two operations here in the same problem, and there's a potential confusion. Now B can be confused because it could be that they think they can again muddle up the order and express this as, well, 2 subtract 6 plus 7. But what's happened is that person A intended that they subtract 2. And so if they're now subtracting 6 and adding 2, then we're not going to get the same result at all. 2 subtract 6 is -4, plus 7 is 3, whereas here we had 6 subtract 2 is 4, plus 7 is 11. So the answer needs to be 11, just as the answer here needed to be 15. So we need to have the answer to be 11. Okay, so what person B needs to realize is that yes, you've got a lot of freedom when you've got addition, but when you're mixing in subtraction, you need to be a little bit more cautious. So what they can do is say, well, I'm always going to subtract the 2, so it's like adding -2. It's exactly the same as adding -2. And now they can quite happily change the order. They could change that to -2 plus 6 plus 7. They could do grouping and associating, and they're going to get the right answer every time. So we've got -2 plus 13 is going to give us 13 subtract 2, 11. So some potential confusion here, but as long as B understands the rule that you must subtract the 2, then everything's going to be okay. Things get a little bit more confusing when person A does something like this. So they say 6 plus 2 times 7. And here we've got more potential confusion, because what they actually mean here is 2 times 7 to be done first. Alright? 2 times 7 is 14, and the 6. The result should be 20. But maybe they should have put brackets around the 2 times 7. They haven't, though. Can person B interpret what the meaning is here? The potential confusion, just to clear that up first, is that we read it left to right, and with an ordinary calculator, this is how a calculator would read this, and that would be 8 times 7 would give us 56, which is nothing like the answer we want. So how do we read this correctly? Well, the rule is that we have to deal with multiplication first. So what person B needs to realise is that this in fact is 6 plus 2 times 7, because there's a rule that multiplication needs to be dealt with before addition and subtraction. So multiplication and division in fact need to be dealt with before addition and subtraction. And the reason why that's the rule is something we can go into in the second part of this video, but for now we just need to make sure B understands that rule. Okay, now that they've got that rule, they can change the order again. So they could say, well, 2 times 7 plus 6, that's fine. We're still multiplying the 2 times the 7, but we've got to make sure we do 2 times 7 first. And that will give us 14 plus 6, giving us the correct answer of 20. So things have got a bit more interesting, a bit more puzzling as we've started mixing these order of operations. And what I'm going to do is, mixing the operations, sorry, I should say, I'm going to now introduce another kind of multiplication, and here we're going to just use squaring. So we've got 2 squared, let's say plus 3 times 7 plus 9, subtract 2, and let's just make that 7 a bit clearer, like this. So we've got 2 squared plus 3 times 7 plus 9 subtract 2. So what we mean by this is 2 squared, which is 4, plus 21, 3 times 7, so that's going to be 25, plus 9 is going to give us 34, and subtract 2 will give us 32. So that's what we intend, but potentially B could make all sorts of different could interpret this in different kind of ways. For example, they might think that this 2 squared plus 3, they could do 2 plus 3 and square that. Well, it's unlikely that they're going to do that, but it's possible, but they should know they're not allowed to, because 2 squared plus 3, in other words 4 plus 3 7, is nothing like the same as 2 plus 3 5 squared, which would be 25. So they probably know they need to do this first, but the potential confusion comes here. They need to know that rule again, that we've got, that with multiplication we have to deal with that first. So person B needs to rewrite this to make sure they're not going to get the wrong answer and that they're going to understand the problem clearly. So we can immediately work out the 2 squared to make 4. So that's okay. But now we've got plus 3 times 7 plus 9 subtract 2. So 2 potential problems here. One is this multiplication that we need to deal with, and the other is this subtraction. We can immediately sort the subtraction out so that we don't get confused by saying that's the same as plus negative 2. And we can sort the multiplication out by bracketing that off so that we deal with it first. So now we can simply work this out. 4 plus 21 then, plus 9, subtract 2, gives us, well, 21 plus 9 is 30, 34, subtract the 2, 32. Now let's do one final one, just to really try and confuse B. We've got 2, let's say, divide by 3. Let's choose any number here, but make sure we use all 4 of the operations. And let's calculate it first to see what the answer should be. So we've got to do the multiplication and division first. Doesn't matter what order we do them in. That one's going to be 2 divided by 3, so that's going to be 2/3. And that one's going to be 2 times 5, so that's going to be 10. So we've got 2/3 plus 7, subtract 10 is going to be negative 2 1/3. Okay, so the answer should be negative 2 1/3. All right, let's see if person B can interpret this correctly. So first of all, they're going to deal with the division and multiplication. The division's up front, so we'll deal with that first. So we've got 2/3. Now we've got our plus 7, subtract. Well, before we write down 2, let's realise that the 2 times 5 is actually 10, so 2 times 5, we bracket off, and that should be enough to sort out our problem. We've got a negative here, but we need to deal with the multiplication and division first, so let's sort that out first. Okay, so I've got, well, let's do it in simple steps so we don't make a mistake. So we've got subtract 10. We can sort out the negative there by saying 2/3 plus 7 plus negative 10. That might be helpful. And as soon as we've got here, we can breathe a sigh of relief because we can now change the order to make things easier for ourselves or group things in different ways. Let's bring the negative 10 up front, for example. Plus 7 and 2/3 gives us our, well, if we think of our number line, it gives us our negative 2 1/3. So what we've done here is introduce you to the order of operations, the idea that you've got to do multiplication and division before you do addition and subtraction, and the general idea that you've got to be terribly careful when you've got potential confusion to rewrite things accurately so that you definitely get the correct result. Okay, so in the second half of the video, why don't we just try and understand what it is that's going on here? Why is it that we have to prioritize multiplication and division before we deal with addition and subtraction? Well, this diagram here hopefully helps to explain that. What have we got exactly? Let's write it down. We've got a square number here, so we've got 4 by 4 square, and a square number we write as 4 to the power 2. Okay? And here we've got an array of 18 counters here, and we've laid out the array in this way, so we've got 3 rows of 6. So we've got 3 times 6. And finally we've just got 1 row of 9, so we just write 9. And already when I describe it in this way, I think you can see that the row here is really the simplest thing to understand. But anyway, let's work this through. So we've got a 4 by 4, and we call it 4 squared, a square of numbers. And here we've got an array which is 3 by 6, so 3 by 6. And to understand what a square number is, which we've expressed in this way, we need to unpack this term a little bit more to say, well, it's 4 times 4. And so immediately we can see that this is slightly more complicated than this. It's a sort of level of complication above. We've had to unpack it to get to the same level as this one here. Now, what I'm going to do is just unpack it a little more, because what a multiplication is, in fact, is repeated addition. In other words, what we've got here is not just 4 by 4, but we can also say it's 4 add 4, and again, add 4, add 4. So we can rewrite that 4, add 4, add 4, add 4. Here, we also want to unpack this. We've got 3 rows of 6, so we've got 6, add 6, add 6, add 6. 6, add 6, add 6. Sorry, I think I did too many 6s there. So we've had to unpack this once, we've had to unpack this twice to get to what? To get to what we've got down here. And the answer when we add all these together has to equal, well, we've got 16 add 18 is 34 and 9 is 43. So there is only one answer when we're adding things together if they're arranged like this, 43. So to get the correct answer, we need to unpack what's going on here when we say this is a 4. This is 4 squared, and we need to unpack what's going on here, but a little less than we had to unpack this, to get down to what's actually going on. We've got 4 plus 4 plus 4 plus 4, plus 6 plus 6 plus 6 plus 9. So we call this the order of operations, the order of operations, because if we're going to get the correct answer and make sure that the problem solver is going to understand things, if the problem solver is going to use a calculator, we need to program the calculator to work in the correct order. In other words, to ignore the sort of order of language, which is to go left to right, and instead say, no, multiplication has to come first, and in fact we have to have the indices first. Now we can change that. We could say, no, I want you to do this first by putting brackets around it. So that would change our instruction, and that the brackets simply mean, well, work with this thing first. But if we don't do that, so let's just remove the brackets. Okay, so remove those brackets. Then we've got an order of things that we want a calculator to respect. So that means you actually get two types of calculator. An ordinary calculator will just mindlessly go from left to right, and it will do the 4 squared first, add the 3 times the 6 plus the 9 in that order, because that's the order you keyed it in. A scientific calculator, though, has been programmed so that it will work in following the order of operations. And the order of operations could be shown like this: brackets first, then any number with indices, so like this number here, and then we need to deal with the multiplication and division, so not a separate thing, because division can be expressed as multiplication, as we've seen in previous videos, so we'll put that like that. And finally we need to think about subtraction and addition, and as we've seen as we were working above, it's a good idea if we deal with the subtraction first to turn it into the addition. So the addition, if you like, is the simplest form that we want to get to, so that we can do all our commuting and associating, make life simpler and get the right answer.